Hey guys, it's your pal Dave from notesandvolts.com, back with another episode of everyone's favorite web series, Dave Makes Your Dreams Come True. In this series, I will take a random comment or email about how to make a project, and I will just do it for you. And I will make the code and the schematics and send it to you and make your dreams come true. So the other day I got an email about someone who works with a band, and the band plays along to, I think, Ableton or some kind of sequencer, and the band is going to give them a 5-pin Midi cable that's going to have CC triggers. What they want is a little box that will take in the 5-pin Midi and convert it into something that can drive like a mains powered piece of gear. I don't know what that is. It could be a bubble machine or a confetti cannon or a Christmas tree. I'm not really sure, but that doesn't matter. We just need something to take that MIDI CC signal and convert it into something that can switch a large voltage and current. Now, normally the Arduino is horrible at this because the Arduino is a little 5-volt device. It can only handle about 20 milliamps out of its outputs. So how are we going to switch a large voltage and current using this tiny little Arduino? Well, we're going to use something called a relay switch. Now, a relay switch is like a little box, and on one side you've got an electromagnet, and on the other side you've got a switch. Think of it like a light switch. When the Arduino powers up the electromagnet, it's going to pull that switch closed and allow whatever's on this circuit to turn on. And then when the Arduino disables the magnet, the switch is going to spring back and break the circuit, and it will shut this thing off. So we just need something to make the Arduino and the relay work together. So I sat down and worked it all out and came up with a little box I'm calling the Midi 2 Relay. And in this video, I'm going to show you how it works, how to program it, and how to make your own. But before we start, I got to give a shout out to a very special company that makes my dreams come true, and that's PCBWay. Thank you again for sponsoring this video. PCBWay is a one-stop solution for all your circuit board and manufacturing needs. They can do circuit boards, multi-layer boards, aluminum boards, 3D printing, CNC machining, injection molding, and assembly. They can do it all. PCBWay is very maker-friendly with lots of services for small creators like myself. So check out PCBWay today and they can make your dream project a reality. Click the link in the video description to let them know that Dave sent you, and you'll get yourself some free goodies. So thanks again to PCBWay. To make this project easy, we're going to use one of these ready-made relay modules. So this is an 8 relay board, and you can get these off Amazon, and they're very inexpensive. They include all the buffer and driver circuits, and they're very easy to use. So I'll put a link in the video description to show you where you can get this exact module. All right, so first of all, let's do a little demonstration of the finished product, and you can see it in action. So as the viewer requested, we have a 5-pin Midi coming into the circuit, and it's coming out of this Midi controller here. And I've got these 4 knobs hooked up to Midi CCs, and each one will control one of the relays. So first of all, let me turn on my power supply, and you will see the indicator light come on. So this indicator light does 2 things. It shows you that there's power, and it will also blink when MIDI commands come in. So it also is showing you MIDI activities, so you can make sure everything's talking to each other nicely. So let's take this first controller here, and I'll start turning it up, and you can see the value here. And you can see the MIDI is coming in, it's blinking. And as soon as I pass 60, there you go. I don't know if you could hear that, but we've got a light indicating this is on, and also I heard a little click from the relay. These are set up right now so that anything below the value of 60 will be an off and anything above 60 will be on. But you can set that in software where that threshold is, and depending on what you need, how sensitive you need it to be, you can set it to whatever you need. Also, even though this is responding to CC, there's also a way to allow it to respond to MIDI notes as well. So you could set this up so your notes could actually trigger the relays. All right, so we got one relay on. Let's turn on the second one. There we go. Third one. And the fourth one. And there you go. We could, unfortunately, I don't have enough CC knobs to do all 8, but they all work. And let's turn them all off. How about that? All right, so I think that's what they asked for. So now let's take a look at the circuit and the code, and I'll explain how it all works if you want to build one yourself. Okay, so let's take a look at the schematic first of all. It's actually not that difficult, but there's a couple of points you want to be aware of. So here's my power input. So this could be just a DC power jack, and you notice we have a note here, power supply, 5-volt regulated only, 1 amp minimum. So this circuit, the relays actually draw quite a bit of current when they're all on. So when you turn all the relays on, this circuit will draw about 500 milliamps or half an amp of current. So we want a power supply that's going to put out at least that. So that's why I said 1 amp minimum. So you always want to give it a little more, a little room for error. So the power is coming in your jack, and that is going to be connected to these 3 pins on your relay board. So over in the corner here, we have 3 pins. We have a JD VCC, a VCC, and a ground. Now, why do we have the 2 VCCs? So the JD VCC is only going to power the electromagnets in the relay. And the normal VCC is going to be available at the VCC on these middle pins, and that's going to power our Arduino circuit and also all the buffer circuits on the relay board. So basically think of it as two separate parts. We've got the Arduino side of the relay board, all these buffer components, and then we have the higher current drawing electromagnets in our relays. Now if you look at the schematic here, you can see the ground is just going to the ground right there, and then you're going to take 2 lines, one to VCC and one to JD VCC from your 5-volt line on your power supply. If you notice, I've put a switch in series with the JD VCC line. That's the ones controlling your electromagnets. You notice I've labeled it an arm switch. So you can think of it as an arm switch or a safety switch. And I thought that would be a good idea. So if this switch is open, this will be a toggle switch. If this switch is open, and I'll indicate that by removing this. All right, so that's the same as if I opened my arm switch. Now, when I run the Midi into it, you can see that the lights are reacting, but the relays are not switching on. And that could be a very good thing, because let's say you're setting up the show, you want to run a test and make sure everything is receiving the correct commands and it's working okay, but you don't want to actually fire the whatever is connected to your relays. Well, that way you just flip the arm switch off, you can watch the lights respond, and then when you're ready to do the show, reconnect or flip the arm switch back on. And now you'll see the relays are actually firing. Now, each relay has 3 pins coming out of it. And basically that's called a normally open and a normally closed switch. So the middle pin here is your common. And then we've got this side, which is normally closed, and you can hear the multimeter responding. And this side, which is normally open. So the normally closed means the switch will be closed until the relay turns on, and then the switch will be broken or off. Whereas the other sides, the switch will be off until the relay is closed, and then it will turn on. So we'll simulate that. I'll put it in the common, in the normally open, and then when I turn my relay on, there you go, off. And the other side will be the opposite. So it should be on until the relay turns on, and then it will turn off. So depending on what you're hooking up, one will be better than the other. So we've got our power and ground coming into here on the relay board. Now this VCC here is going to power our Arduino. So basically this VCC and the VCC on this group of pins are connected. So the power is going to come in here, and then it's going to be available here. Now on my Arduino, I'm going to put that power into the 5-volt pin, not the V-in pin, the 5-volt pin. Now this is why we have to make sure that we have a 5-volt regulated power supply, because we're bypassing the internal regulator on the Arduino. So if we give it more than 5 volts, we can blow it up. So make sure you're only putting 5 volts into the 5-volt pin. So also the ground here and this ground are tied together. So we're going to take this ground, and that's going to be the ground for the rest of our circuit as well. Now for the digital outputs, notice I just have each output on the Arduino from D2 to D9 going into the inputs on my relay board. So all you have to do is connect the wire from one to the other. And here is our Midi input circuit. So we've got our Midi jack, one diode, a 1N914, and a 6N138 optocoupler for protection, and a couple of 220 ohm resistors and one 4.7K resistor. Now here's another very important point. You notice I have a jumper wire indicated on this connection from the Arduino's RX or receiver pin and the output of the optocoupler. Now we need to be able to break this line, because when we try to program the Arduino, this RX pin and the Arduino's USB input use the same connection. So if I have this hooked up to my Midi input, the program is not going to be able to come in, and you'll just get an error in your software. So as it says right here, remove the jumper for Arduino programming. So when I'm programming, I got to make sure I remove this cable and then send the program in, and then reattach it to actually run the program. Now this leads me to another very important point. You notice this note up here. Do not connect USB cable to Arduino while external power supply is connected. So right now we are sending the 5 volts from our external power supply into the 5-volt pin. When you connect the USB cable to your Arduino for programming, I'm also going to be sending 5 volts from this cable into the Arduino. So we basically got 2 power sources going into the Arduino. That's not good. You don't want that. So when you are ready to program this, make sure you remove your external power supply. I'll just turn it off here. Right now this is off, so this is unpowered, and then you can connect your USB cable and power it that way. Send the program up, and then when you're ready to run it, remove the USB, and then you can repower it with the external supply. Okay, but the main takeaway, do not power it with the USB and the external power supply at the same time. Okay, now let's take a look at the code and how you configure it for your application. So here is the program. It requires one library, the Midi library by Francois Best. And here it is included here. You want to make sure you have it. If you go to Sketch, Include Library, if you move down, you should have the Midi library. If you don't, go to Manage Libraries. You can do a search for Arduino Midi, And you want to scroll down until you find MIDI library by Francois Best, and just make sure you have it installed. Okay, so once you have your MIDI library installed, you're ready to upload the program. Now here's a few things you can set to customize the program for what you want to do with it. So this program, like I said, will work with notes or CCs. If you want it to respond to notes on your keyboard, set this value to true. If you want it to respond to CCs, set it to false. Now this next section will let you set the MIDI channel that your circuit's going to listen to. So if you set it for 0, it's going to be in omni mode, which means it will respond to any MIDI channel that comes in. If you need a specific MIDI channel, just set it from 1 to 16. So if you set it for 2, it will only listen to MIDI channel 2. Now this value here is the on limit. As we saw earlier, the relay won't turn on until my MIDI CC reaches 60 or above. And that is where I set that. So you can set this from 1 to 127. So if I set it to 1, basically 0 would be off and anything above would be on. If I set it to 127, then basically 0 to 126 will be off and 127 only will be on. Also realize that this will also work for the MIDI note, but this will be your velocity value. So if I hit the key very quietly and I get a velocity below 60, then the relay won't trigger. So if I need this to be really sensitive, set it to 1, and then any velocity at all that I touch on the keyboard will trigger the relay. If I need it to be super not sensitive, set it to 127. That means only the hardest press possible will trigger the relay. This next section is where we set the note or CC value. So each relay can have its own value, or if you want, you can set multiple relays for the same value. So let's say I set these for 60, that means when MIDI CC or MIDI note number 60 came in, all 4 of these relays would trigger at the same time. The rest of the program is stuff you don't really need to touch. These are the pin numbers for the relays. If there's some reason you need to change them, you could change it here, but I would just leave those alone. The external LED also is on pin 12. You could change that, but once again, I would just leave it as is. And the internal LED, you only need to change that if you're not using a Nano or Uno type of board. Once you've configured everything, you can program it to your Arduino. Now remember, we had a couple of things you have to watch. First of all, before you plug in the USB, make sure you disconnect this power supply. So I'm going to turn it off. Right now we have no power coming in here. So now I can plug in my USB. Now I'm getting power through the USB. The second thing you have to do is make sure you unplug your MIDI input cable from your RX pin. Once you've done that, you're ready to program. So go to your Tools menu. Make sure you have your Arduino Nano selected. If it's a genuine Arduino board, you'd probably want to use this setting at Mega 328p. If you have trouble with that, if you're using a knockoff Nano board, you might want to use the old bootloader option. Make sure your COM port is selected. Once you plug in the Arduino, you should get a COM port, and for me it's COM 7. And then just hit upload and the program will go to your Arduino. Once the program's up there, make sure you reconnect your MIDI input and disconnect the USB, and then repower it with the external power supply, and you should be good to go. Okay, let's get building. First step, grab yourself a shiny new breadboard. Now take your Arduino Nano and put it on the left side of the board with the USB connector pointed towards the left. Now we got to connect power and ground. Take two little jumper wires and connect one to the GND pin, that is the ground pin, and jump that to the blue negative rail on your breadboard. Now take a second piece of jumper wire and take it from the 5-volt pin labeled 5V to the positive rail on your breadboard. Now we'll hook up the indicator LED. Take a long piece of wire and run it from pin D12 on your Arduino to somewhere past the board. Now grab an LED and connect the anode or positive side to the wire we just installed. Jump it across the middle of the board and connect the negative side or cathode through a 470 ohm resistor to the ground rail. Next we'll install the 6N138 optocoupler. Place it on the board with the pin 1 mark pointed towards the right. In this orientation, the pin numbers will be like this. Now we'll power up our little friend by connecting a jumper wire from pin 6 to the ground rail. Then take a second jumper wire from pin 8 to the positive rail. Next we'll take a 4.7K resistor and run it from pin 7 to ground. Now take a 220 ohm resistor and run it from pin 6 to the positive rail. Make sure these resistors don't touch each other. Now we'll install the tiny little 1N914 diode. One side of the diode will have a stripe on it. Put the stripe side to pin 2 and the other side to pin 3. Next we'll add a piece of jumper wire from pin 3 to any place you want your Midi jack to sit. Next we'll install a 5-pin Midi jack. When you look at the back of the jack, the pins are numbered like this. Place the Midi jack so the wire coming from pin 3 on the optocoupler goes to pin 5 on the jack. Next, take a 220 ohm resistor and run it from pin 4 on the Midi jack to pin 2 on the optocoupler. To complete the Midi in circuit, we'll take a long jumper wire from pin 6 of the optocoupler to the RXD pin or receiver pin on the Arduino board. Alright, we are ready to hook up the relay board. First of all, I'll flip it around so the pins line up with my Arduino. Now, on the middle pins on the relay board, we're going to take a cable from the ground or GND pin and run it to the blue ground strip on the main board. Now I'll take a second cable and run it from the relay's VCC pin to the 5-volt positive strip on the main board. Now we just have to run the relay's input pins to the digital outputs on the Arduino. I'll start with digital pin 2 on the Arduino and connect that to input 1 on the relay board. Now just run the rest in order. So input 2 on the relay will go to D3 on the Arduino, input 3 will go to D4, all the way up to input 8, which will go to D9. So now we just have to hook up our main power supply to power the whole project. I'm using a 5-volt regulated 1 amp power supply for this project because the relay board does take quite a bit of current. First, connect a wire from the ground terminal of your power supply to the GND pin located at the corner of the relay board. Now from the 5-volt terminal of your power supply, we're going to take 2 lines. One's going to go to the VCC and one's going to go to JD VCC.
All right, everyone, there you go. Another dream fulfilled through the power of electronics. I hope your show goes well and your confetti cannons go off in time to the music. But before we go, as always, I got to give a special shout out to my patrons on Patreon. Thank you so much, guys, for helping me do all this stuff. And let's enjoy your names on the screen.